People are driven by the search for better. But when it comes to hiring, the best way to search for a candidate isn't to search at all. Don't search, match with Indeed. The hiring process can be slow and overwhelming. Simplify hiring with Indeed. Indeed is your matching and hiring platform. With over 350 million global monthly visitors according to Indeed data, and a matching engine that helps you find quality candidates fast. Ditch the busy work. Use Indeed for scheduling, screening, and messaging so you can connect with candidates faster. Join more than 3.5 million businesses worldwide that use Indeed to hire great talent fast. Listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. That's Indeed.com/PODKATZ12. Terms and conditions apply.
You're listening to the Archaeology Podcast Network.
You're listening to The Archaeology Show. TAS goes behind the headlines to bring you the real stories about archaeology and the history around us. Welcome to the podcast.
Hello and welcome to The Archaeology Show, episode 222.
On today's show, we talk about handedness in the archaeological record.
Let's dig a little deeper, but those right-handies people probably won't even let us. I don't even know. Shovels are biased. I'm out. All right, welcome to the show, everybody. How's it going?
Good.
Why do I say the same damn thing every time?
You do, and then I say good every time.
You're not good,
Not
though.
great, not perfect, not amazing, just good.
I'm hot and I'm burning up. I need more solar and I need more lithium.
I know. I think you're going to be a bit punchy this episode because you're hot angry right now.
I am.
Some people get hangry. You get hungry. No, that's not right.
I think it's the same thing.
Yeah, I guess it kind of is.
Yeah, it's just an H.
You're just hungry.
Yeah, it's all the H things I get angry about. Yeah, no, we're in Shasta, California, actually.
Yeah.
We came over from Reno where we spent a few days. And even though we can see Mount Shasta, which has 7 quadrillion gallons of snow on it.
It does.
Yeah.
Like more
Maybe
snow than
cubic feet.
Right.
Yeah.
It's more snow than I've ever seen on it this time of year.
Yeah. In June.
Probably more snow than I've seen on it in like April.
Yeah.
You know, it's just a lot.
Yeah, it's a lot.
Yeah.
But the city of Shasta, however, had a high of 92 today. So it's not quite that now, but it feels nice and warm inside the RV here. So
Yeah. I'm not sure I'd say nice.
That's
but
not nice.
Warm.
Yeah.
Warm is accurate.
Indeed.
Yeah.
If I wasn't able to get the fan sounds out, we've got the fan sucking air out of the ceiling, and we've got our Dyson on too, and it's just, it's a lot.
And we have windows open and like traffic going by too, but like we're just going to have to live with that because it's so hot in here.
Yes.
For those who don't RV, they're very hot inside.
Yeah.
Even when it's cooler outside, because it's cooling off out there, but it's still very hot in here.
Yeah.
So
Yeah.
I digress.
All right. Well, I am left-handed,
Yep.
and we deal with this. Yes, we deal with this almost daily because even just last night we were out to dinner with friends.
Yes.
And on a table set up where there's 4 on one side and 4 on the other side, like I can only really sit in 2 places without pissing somebody off.
Yeah.
And we ended up even moving me down so I could be more in the middle because it was all really my friends. And I just, I was elbowing you the whole time.
Entire dinner.
It was actually a pretty tight table too.
It was very tight.
Yeah.
Yeah.
And it was steak, so it's like knife action.
It's like when I met you, 18 years ago or whatever, I didn't know that I was going to have an elbow in my face every time we went out to dinner for the rest of my life. But I guess that's what I committed to when I married you.
It is. So about a month ago, it got me wondering, when did handedness develop?
Yeah.
At first I thought, has anybody researched this?
Yeah.
And then I was proved stupid because of course people have researched this.
Have. Yeah. They've researched everything.
Yes. So first, just a couple of stats here. 85% of all people in all populations are right-handed for most manual actions. Okay, and that is astounding. That's not just penmanship. I know.
Right over here.
But why? Why 85%?
Yeah,
it's not like it's
a lot.
50-50.
No.
There's a reason for it,
Yeah.
right? It's not random. It's not...
It still could be random, but...
Well, it's... Yeah, I mean, I actually am not sure... Well, we'll get into this a little bit later.
We'll get there.
Because there are some reasons for it. And you're right, it's actually not random. It can be inherited. So anyway, no other great ape species shows such strong population level bias. And that's a key phrase there, population level. Because individually, some great apes do show a preference for a hand, but there's not like this 85% of them use one hand over another.
Yeah.
There's more of a, it really is more symmetrical.
More of a 50-50. Yeah.
Yeah. So,
and it might be that they're more ambidextrous too. Like they switch back and forth between different hands to do different tasks.
Right.
Yeah. So
one of the things this might indicate, since we share most of our genetic code with the other great ape species, notably chimpanzees, but all the other ones, what this really means is if they don't have a strong bias towards right or left-handedness, and we do, then our bias towards right-handedness or towards one direction or another, no matter what it was, must have developed after our last common ancestor.
Yeah. And if you're not sure what that means, go listen to our paleoanthropology series we did a few months back.
Yes.
And we walk through the entire prehistory, pre-man tree.
I don't know if I'd say entire.
Well, not entire. Like we did the best job we could in like 4 episodes or something like that. So yeah.
In reference to this, in case I forget, we just finished editing the Life in Ruins podcast, episode 161, which comes out the day after this one does.
Yeah, great episode.
Yeah, they're talking about a paper regarding Homo naledi, which is an ancestor, and they
it's kind of the newest one, right? Like,
yeah, it's
I think
one of the newer ones,
we talked about it in our series as well.
Yeah,
very briefly,
for sure.
Yeah.
But there's evidence of them actually burying their dead intentionally, so that's a pretty cool episode.
Yeah,
check that out. Anyway, to look at the difference in handedness in humans and kind of how this developed and trying to figure out when this developed, researchers look at a number of things, notably though prehistoric stone artifacts, and the only real reason for that is the farther back you go, that's like the only thing left. The only thing that we can really look at.
Yeah.
We can look at rock art 30, 40,000 years ago in some cases.
Yeah, but rocks and stones.
Yeah.
That's what you've got left over. And those things that are organic that might have turned to stone.
Yeah.
Through fossilization, you might have some of those, but those are even fewer in the archaeological record. So
yeah, now using these tools, right side bias is well established from Neanderthals onward because there's a lot of archaeological evidence for the Neanderthal, genus and species.
We have a lot of tools.
All the way down.
We have a lot of examples of skeletal remains, so we have a lot to.
We even have don't we have like clothing or something like that, like furs or something?
I think so.
From Neanderthals? I can't remember.
Like there's some really great preservation where you do get some of those organic items preserved. So we have some.
Yeah, there's little evidence from anything older than that.
Yeah.
From fossil and artifacts.
Yeah.
We're going to talk about some other stuff in here, but and I'm kind of glossing over this on the first segment. You'll find out why here in just a minute. As I mentioned, the great apes don't have a bias towards one or the other, but like I said, group level hand preference has been observed in chimpanzees and other apes for skilled tool use and food processing. So that kind of indicates that, hey, if you've got a strong member of the group that might be teaching culturally how to do something, because animals do that, of course, they train their young, and if they're using their left hand to put a stick into an anthill to pull out the ants, and eat them, then their young are probably going to do the same thing.
Which absolutely makes sense.
Yeah.
And it makes sense that it would be limited to the population level because that kind of behavior doesn't normally get shared outside of their population or their family or whatever. So that makes sense.
And if there were a bias like there was in us, it would have to be something that was genetic.
Yeah, it would. Yeah.
Which is another thing that tells you that our right-hand bias has to be genetic. It's not learned behavior. And in fact, parents have tried to out lefty their kids and make them right-handed, and it often goes terribly.
Yeah, for sure.
Yeah.
And the thing to remember about genes too is that they're weird, and the things that get selected for in genes are not always what you would think. Like we have an appendix and we don't need it. Like there's a lot of weird stuff in our genetic code, and this could fall into that. Like maybe it's selected for no reason. Maybe it just happened because genetics is weird.
Well, and something interesting about genetics, we were driving today and I was listening to this book called Outlive. I can't remember the name of the author, but look it up. It came out within the last couple of years. He's basically a surgeon, a doctor, not a surgeon. He's a doctor. And he wrote this book it's a book on longevity. Now there's a lot of books about that, but his take on things is not how can we live longer necessarily, but that's what it ended up being because his focus of his research, he was tired of dealing with disease once it happened.
Yeah.
And he wanted to start looking at how do we prevent the thing from happening.
Which is smart.
Right. And but one of the things he said in a portion of it that I listened to today was related to genetics. And he was like, people have asked him before because he's talked about this a lot, and I've never heard this question actually asked, and I've never thought about it. But if natural selection has spent the last hundreds of millions of years selecting all the good traits that allow us to be successful and thrive, why do we have cancer? Why do we have male pattern baldness? Why do we have dementia and Alzheimer's and stuff like that? And the reason is because natural selection doesn't care about us once we're, 40, 50 years old.
Doesn't care what we look like.
It doesn't.
It doesn't care if you remember your children after 70 years. It cares about the early stuff. And as long as you can reproduce at least once, that's where natural selection passes on the genes. But once these other things express themselves, the gene is already there in your body, and you're passing it on without even knowing it. Right.
But if you say, went bald at 15 because of a gene and made you less attractive in whatever society you're in, then your gene is going to be selected out.
Exactly.
But if you don't go bald until you're 50, nobody even knows you have the gene.
Yeah, it's kind of like the BRCA gene too for breast cancer in women, right?
Yeah.
Yes, if you have that gene, you're more likely to get breast cancer, but it's probably going to be after you've already had whatever children you're going to have.
After you've already submitted your code.
Yeah, exactly. already submitted your code. Oh my God. That's so robotic, but also so perfect. I love it.
Right.
Yeah. So genetics are weird. That's what it comes down to. And I mean, that's a really little statement for a really big thing because they're not weird. They have a very specific purpose. But for me, that's how I have to think about it. Like you just don't always know what they're doing and why,
right?
What it's getting selected for and why. So yeah.
All right. Well, I'm going to read a paragraph straight out of one of the sources that we have down in the references.
Yep.
So take a look at your links. There's a lot of stuff down there. And I kind of pulled in a bunch of stuff and pulled little bits and pieces from these for research on this podcast. So this will be a little bit of an academic jargon trigger warning for you people that don't like this. I don't even like it either. Some of these articles
really
they're hard to read because there's a citation every 4 words.
Yeah.
It's like, did you write anything original in this?
Right.
But anyway, the quote is, when primatology meets paleoanthropology, the evidence suggests species-level right-handedness may have emerged through the social transmission of increasingly complex, bimanually differentiated tool-using activities. End quote. So what that means is primatology is us.
Yep.
And paleoanthropology is our ancestors in the past, typically fossilized. So really, really far past. And they're saying that species-level right-handedness emerged through the social transmission of increasingly complex, bimanually differentiated tool-using activities. So we're saying tool-using because that's what we have to look at right now, right? So we're assuming maybe that was one of the things because they were doing it. So what they're saying is that through the use of tools and the creation of tools and the social transmission of that information, and the more complex it gets, that this started, I guess, for lack of a better way to say it, I'm not a geneticist, but sort of rewiring the brain. And then those traits were being inherited, So we've got some other stuff to talk about.
Yeah.
And I'm not totally sure that is 100% how that went down, but there it is. So, all right. Well, we've got a little bit of a surprise here. We wanted to talk about this ourselves, but I also wanted to bring in somebody who had actually studied this. And when I was looking for resources, a name came up and a master's thesis that I found, and it was Lana Ruck. Now, anybody who listens to other shows on the network, notably Life in Ruins podcast, knows Lana Ruck. She's been on, I think, at least
times.
2 or 3 episodes of the Life in Ruins podcast. Yeah. And what she did her thesis work on for her master's degree was handedness.
Yeah.
And it was super cool.
That's awesome.
Yeah, so I tracked her down and nailed her down for just a single segment. It's a little bit of a longer segment, but I think you're really going to enjoy this. So let's take a break. And while we're taking that break, listen, we're trying to help everybody out at the podcast network here. So just take a glance down at your phone or your thing, whatever you're looking at this on. Maybe click through one of the little affiliates we have down there, and we get a little kickback if you do something with that affiliate.
That would be great.
And they're not just garbage. There's actually some good stuff down there. So while you're listening to these ads, maybe take a glance down. Hopefully you're not driving, and click on one of those. And if you buy something, we get a little bit of a cut. So that would be super awesome. Anyway, we'll be back in a minute. And on the other side, we'll be talking to Lana. Back in a second.
Chicken tacos should only be trusted to chicken professionals. That's where we come in. Introducing Zaxby's new chicken finger tacos. One comes with pico de gallo and creamy chipotle ranch. And the other comes with bacon, lettuce, tomato, and avocado ranch. Chicken experts since 1990. Chicken taco experts since now. Order yours today in the Zax Rewards app. Woo, saucy! Zaxby's.
Save on O'Reilly Brake Parts Cleaner. Get 2 cans of O'Reilly Brake Parts Cleaner for just $8. Valid in-store only at O'Reilly Auto Parts.
O'Reilly Auto
Auto Parts. Chicken tacos should only be trusted to chicken professionals. That's where we come in. Introducing Zaxby's new chicken finger tacos. One comes with pico de gallo and creamy chipotle ranch. And the other comes with bacon, lettuce, tomato, and avocado ranch. Chicken experts since 1990. Chicken taco experts since now. Order yours today in the Zax Rewards app. Woo, saucy! Zaxby's.
Welcome back to the Archaeology Show, and we're doing something a little bit different this segment. I did some research, and if you look down in your show notes, you'll see links to this stuff, but I found a past guest on another show on the Archaeology Podcast Network, and I kind of knew her through editing her, but I don't think we'd ever spoken before. So I reached out, and I wanted to mention, again, look down on the show notes and you can find her thesis. But Lana, welcome to the show for this short segment to talk about your thesis research.
Thank you. Thank you for having me.
Yeah, no problem. So tell us a little bit about what the main thesis of your thesis was, so to speak.
Yeah, so the thesis was actually born out of an idea I had as an undergraduate. I was in a human evolution class and had to write a term paper. Mm-hmm. And my question was, when did humans all evolve to be right-handed? Or, primarily because we have so few left-handers. And no other species on Earth is like that. So it's definitely unique to us. And that kind of led me down a path of, well, how could you tell when handedness prevalence for right-handers evolved? And the best answer ended up being potentially to go ahead and look at the archaeological record and evidence for handedness potentially in the earliest and the stone tool record to see if you could find evidence of shifting handedness using those present materials that preserve as long as they do.
Right. Okay. Yeah. Because stone tools going back far enough, that'd be about the only thing we could look at, right? Because there's, I don't know if you know this or not, but do you know if there's any sort of indication on even modern people that, on your skeletal remains that you might be dominant in one hand or another? I don't imagine muscles develop any differently unless you do something specialized, do they?
Oh, yeah, no, there definitely is. So there are other markers. And I actually kind of go through that in the thesis, like what have other people used? Definitely bone asymmetry is one of them. But once you go further and further back in time, the requirement for having full and complete paired long bones that you can identify for a single individual, you're looking at like Turkana boy.
Sure. Yeah, that's about it.
So it gets really difficult. Other people have used asymmetry in internal dimples in the brain. I don't want to get to, neophrenology or anything. I think there are really big problems with that approach, but there is some evidence that you can tell handedness or dominance from dimples on the inside of the brain, which is a whole other part of the story about handedness and brain organization. And that's what I did for my doctoral research. What other ways? People have actually used teeth to detect handedness, which is really interesting. This is specifically in Neanderthals.
Okay.
It's because they did so much work with hides and they would use their teeth as a third hand, and do hide scraping where you hold the hide in the non-dominant hand, you put the other pressure, the tension with your teeth, and then you scrape with your dominant hand, right?
Okay.
And if you do that for your whole life, you end up with these micro striations on your teeth that are directional in the same direction that you were scraping in.
Wow, that's really interesting.
But that only works for a particular sample, right? You have to have enough teeth. You have to have the right setup for the scanner. You have to, that's only considering one species.
Sure.
So once you do all of this math of like, what are your sample sizes? What's your availability of what you're going to work with? It really ends up being, stone tools are the most robust record, but we just have to figure out, can we detect handedness in them?
Okay. I think I've seen other studies before about detecting handedness in stone tools. And I think one other thing we could mention too is rock art, detecting handedness in rock art. Yeah.
Sorry, I forgot that one. I knew I was missing something, but it's been a while, That's a huge one.
Yeah, because people have specifically I don't know, painted outlines of their hands and sometimes like as a signature, right? And you would almost assume that they would do their dominant hand with that, but there's probably other indications we could look at as well.
Yeah, no, there are definitely naturalistic studies of things like this that people have done to see, like let's say you go to a fair or, like a flint napping event, a napping or something, and you just have a wall up there and you just observe them, do a count of how many kids are going to go up there and like use their non-dominant hand if you know their handedness.
Yeah.
There's tons of stuff out there about the rock art and, whether it be direct press or stencil. Natalie Uomini is a person who's done a lot of that. Her last name, Uoimini. Yeah.
Okay.
She's out of the UK somewhere. She's hopped around a bit.
So going back to lithics.
Yeah.
I'm curious as to, really what some of the specifics are to, what you can look at to look at a stone tool and say, how do you look at that and say what handedness a person was when they built that? Because my knowledge of lithics, and I've done a little bit of flint napping and I'm a CRM archaeologist, so I've seen quite a few projectile points, but you flip them over, you do both sides, they're bifacial.
Yeah.
I'm just like, how can you determine handedness from that? What do you look for?
Yeah, so I'm actually going to go like full circle here on you. I really kind of planned this to be a life's work, right? Because the stone tool record is huge. So if you got a working method, you could never stop. But so it all starts at a basic principle, right? With that Hertzian cone fracture, the basic principle of stone tool making, and how the direction of that, initial blow going out through the stone in either centered or skewed patterns, right? Skewed to the left, skewed to the right. And there are all these different markers that people have tried to look at, as many as like 20 or something for the European team in the early 2010s. And it's like the bulb of percussion, the ripples, the hackles, are there aurelian scars? Are there any ridges on the bulb of percussion? What shape is the platform? What area on the back of the piece or has cortex, if any.
Okay.
And so they looked at all these things to see if there's any correlation between that and the handedness of the napper. And let's say you're looking at like unifacial, like directional circular reduction of a core.
Okay. You
could easily sort that out, right? There's not enough variance in the system for it to be too, complicated. But once you're making something like a 500,000-year-old Acheulean hand axe that's like very refined, there's so much variation going on that I, at this point, think it would be really difficult to answer that question because there's so many things to consider. And these are all things that, we would talk about endlessly in my lab, right? And we would design the experiments that we would want to do on it, realize we don't have the budget for the rock and give up. And, nor any, the availability of nappers who are going to come unless you're going to go out and find them and convince them to be in your study. And then you got to tow the rock. And I'm sorry to say, but scientists are not really great at that. Some of them are, not me.
Yeah. Right.
But so, there are logistical difficulties to doing a big study of trying to get a sample size large enough to sort all that variability. But let's say detecting the number of nappers at a site.
Right.
Unless you have distinct scatters with distinct material types,
Okay.
From a mixed assemblage, it's going to be... My approach in my master's, based on some publications near that time, was, can you tell from a single flake? That's what people were doing at the time.
Wow.
You would need a lot more help from that in the input. Because at this point, what you're using to try and help you detect these, your input would be all your measurements about the stone. And then your output would be the algorithm's guess, whether it be a statistical algorithm or, some machine learning thing or, some fancy AI black box. We don't know. It spits out an answer left or right. Right. Bayesian. I forgot that.
Yeah.
That doesn't really give you an answer.
Going off the analysis and AI and stuff like that. I mean, AI is a hot topic right now, of course, with ChatGPT, and seems like it just exploded onto the scene, to be honest with you. And now people are talking about using AI for all kinds of stuff that they weren't even thinking of before. But, you just mentioning, scans and being able to tell from one flake kind of thing. It seems like if we had enough, really good flint knappers, not just beginner flint knappers, but people who knew what they were doing, right-handed and left-handed flint knappers, creating the same objects and then taking very, very highly detailed scans of those things, dropping those into a computer and doing some deep learning, some machine learning on that. It almost seems like if it were possible, we could just toss a flake into this thing after it learns enough and say, yeah.
You could do it probably for one assemblage and it would take you your life because of how long it takes to scan an item. Yeah. How long it would take to pre-process that kind of data. And because flakes in particular and stone objects, really, they are really hard to scan.
Yeah, I bet.
We wouldn't ever use obsidian because that's stupid as hell for a scanner. But even if you're using the most opaque, some chunky quartzite, in every single scan, you're going to get pixel you have to edit out. Even if you get a computer program to edit those out, you could stack as many automated tools, black boxes as you want on a computer process. Right. And here's one problem. And I really learned this in my dissertation when I was doing this exact kind of work, not on scanning the lithics at this point, but on scanning brains to look at brain activation for stone tool making. Right. The more black box shit you're doing, sorry to say it, the less replicable and less interpretable your results get because you don't know what those algorithms are doing. So bad data in would be bad data out. And, when you do experimental studies on handedness and stone tool making, you're always going to find an issue of left-handed expert flint knappers. For my thesis, I was mailing rocks halfway across the country and they were mailing them back to me because that's the only way I could find them. And then one guy bailed on me and I had to drive myself, 7 or 8 hours into rural Georgia for an emergency. I was like, I found the closest napping in the nearest month. We're all going to go and hope that there's a left-hander there. And there was one.
It sounds like as a left-handed archaeologist myself, I should really learn how to flint knap. I'd have a pretty solid career, it sounds like.
Well, that's
giving researchers tools.
Too. It's like, I am the worst at flint knapping. I can't do it at all.
Right. Oh, man.
So it's a fascinating topic, but it would be a lot of laborious and dedicated, tedious work to figure it out. And I think one thing I would say that I wish I had kind of gotten out in the world before I left academia was there's enough other context with all the other research that people have done, with other species, within neurosciences, and all these other places that we can be confident about a general timeline for when handedness, language, and, higher cognition, those types of things evolved. And people are starting to publish that kind of research now. It's coming out. They're continuing to do it. It's exciting. So a
couple of quick questions here near the end of the segment. Is there any, or have you heard of any possible genetic evidence, like any sort of gene expressions that could indicate handedness?
Oh man, that's so complicated. That's so complicated. So the shortest answer is that people have put heritability of handedness at 25%, which is actually quite low. I'm trying to think. Let me quickly.
Yeah, well, while you're doing that, just looking at my own family, I've got one brother. My mom comes from a family where she's got one sister and one brother. And of her siblings, her brother was left-handed. Nobody else was. My brother's not left-handed. Nobody in my dad's immediate family is, as far as I know. He comes from a 5-sibling family, and none of them were left-handed. And then my grandparents on my mom's side, where my left-handedness seems to go just because of my uncle, my grandparents weren't left-handed either. So I don't know how far it comes down, but it's very low.
I mean, handedness research is probably my favorite part of what I did in the end. It kept me going because it's so fascinating. So, the heritability for handedness is 25%, whereas for height, it's 80. So handedness is like one of those things that has a really strong environmental component. And here's the real thing, especially behaviorally. If you're a lefty in a family full of right-handers, I promise you this without knowing it, you behave a lot like a righty. You use your right hand a lot more than your left. But if you're a lefty in a family full of lefties, you guys are really lefty. So it's very, very social contexty, how you learned, who you got taught from. You know, we live in a very right-handed world, so left-handers are forced to accommodate or self-accommodate. You are forced to assimilate. That's the word. Yeah. You know, so that doesn't help. But handedness research is so cool, and there are way too many genes to track. There are thousands of papers on them.
I bet. Yeah. So one final question for you then is, do we have any idea, or what are the current theories that you're aware of on perhaps I guess why handedness developed in humans and not any other species? Do we even close to understanding that?
Yes. That's a long answer though. I'll start with this. Other ape species have hand preference at an individual level, where every ape has a right hand or left hand preference. Not every, but most. So there's some history there. They're not like us in how much, because they don't do as much differential bimanual skill, where each hand has to do a different coordinated task at one time. What's a really good example of a complicated bimanual task that gets you a really big reward that helps build a really big brain that could maybe ratchet effect in a kind of circular way? Stone tool making. So you kind of build the need by needing the tool. You kind of learn the task, and this bimanual stone tool manufacture kind of pressures the brain to divide tasks. And that lateralization in the brain, that extra kick to push the brain to push tasks to one side or the other, kicks the handedness from individual to individual further and further. And as for why it went right versus left, that goes all the way back to like fish evolution.
Really?
And it relates to how brains organize visual spatial attention to the right hemisphere and other kinds of processing to the left hemisphere. And it has to do with defense versus eating. It's crazy stuff. Crazy stuff.
Wow, that really is crazy.
And if you read all the other papers I wrote, there are bits and pieces of it in there, but you'd have to read a lot. I'm sorry.
Right. Well, it sounds, I mean, as with all things in science, it's way more complicated than I ever assumed it would be. And, you know, and I guess that just kind of makes sense. But we're at the end of this segment. I really appreciate you coming on to tell us all this. This has been just fascinating. And it almost seems like we need to have you on for another show just to fully talk about this for an entire hour, maybe sometime in the future. I
could talk about it for decades.
Right. Maybe we'll have to create a handedness podcast, handedness in archaeology, just have a whole show about it, a whole, many episodes, but indeed. All right. Well, thanks, Lana. I really appreciate it. And for the listeners, take a look down at your show notes and you can see Lana Ruck's thesis link. And we've got a bunch of other links in there too, so you can do your own research and read on some of these topics. We'll be back in a minute with another segment.
America. We are endowed by our Creator with certain unalienable rights: life, liberty, and the pursuit of happiness. At Grand Canyon University, we believe in equal opportunity, and the American dream starts with purpose. To serve others in ways that promote human flourishing and create a ripple effect of transformation for generations to come. Find your purpose at Grand Canyon University. Private, Christian, affordable. Visit gcu.edu.
Welcome back to the Archaeology Show, episode 222. And wasn't that interview with Lana super cool?
That was so amazing. She seems like such a cool person, but also her information was better than the hours of research we spent before being able to talk to her.
Hey,
right?
Go figure. When you find an expert in this or somebody who's actually studied it.
Talking to her for 20 minutes, I feel like we learned more. And I wasn't even on the interview, but I listened to it later. And that 20 minutes was more informative than just reading a bunch of stuff. So it was great.
Yeah. So got any thoughts coming from that right away?
Well, I loved all the social inheritance of handedness stuff. And we kind of talked about this at the end of segment 1. And then you and Lana talked about it a little bit too, but how handedness could have been inherited in a population because the people doing the teaching were teaching it one way. And then if that way was all the same hand, then that could be inherited by the whole population, and then extrapolate that out to the entire human genome. So what I was thinking about that was I actively participate in squashing leftyism when I teach people how to knit.
Yeah, that's why I can't knit.
No, that's not why you can knit. So from a social teaching standpoint, I'm right-handed, and I have had some left-handed students in the past, and at first, earlier in my career where I would be teaching, I would try to teach them left-handed. I'd have them sit facing me and you do this mirrored thing. But honestly, it never worked very well. They were in a sort of institution where everything else was right-handed. Patterns were written right-handed, and they would be trying to reverse it, and it just wouldn't work well. So I got to the point where I was like, look, I know you're left-handed, but knitting involves two hands, and I'm going to teach you how to do it the right-handed way, but don't think of it as the right-handed way. Just think of it as the way that will allow you to knit and follow all of the patterns in the world, because this is how everybody does it.
Yeah.
So I'm actively squashing leftyism in the knitting community.
Well, that makes me actually think, I mean, not to bring this all around knitting, but it has to do with handedness. So do you have to mentally rewrite the pattern if you're a lefty?
Do. If you want to knit lefty. So right-handed people knit from the left to the right. You take the stitches on the left side and you move them to the right side.
Yeah.
Now a left-handed person would go the other direction. And if you're doing that, then you also have to reverse the instructions. And I'm going to stop talking about it right there, because I never tried to get past that or think beyond that, because it gets so confusing when you're thinking about how to do that. But if you start thinking about it, when you're looking at the right side of a piece or the left side of a piece, if you're coming at it from the opposite direction, you have to knit it the opposite direction. So
that could be a little niche if you just if you converted all your patterns to left-handed and had a whole website called Left-Handed Patterns.
Yeah, and talk to just the 15% of the population that's left-handed. Yeah. But I'll tell you what, other knitting teachers out there are squashing leftyism in knitting too. Most people that I know that knit that are left-handed just do it the right-handed way. So But I would love to hear if there are people who knit left-handed and go through all the effort of converting them to go the other direction.
I can't even scissor right-handed, so,
The tool part of it is hard.
Yeah, it's really hard.
Yeah.
Anyway.
Yeah, sorry. That was a little random story.
So I want to pick out some stuff because, we're not going to rehash the interview with Lana necessarily, but I got some stuff to talk about that.
Yeah.
But from one of the other resources, I want to talk about that next. But before we get there, I wanted to talk to something because right near the end of the interview, I asked her about what is the consensus here? Where do we really think all this came from? And why right and not left?
Yeah.
And that was super interesting to me. And, where she said the fact that it's right side, first off, probably goes all the way back to fish evolution, which was super cool and she just chose fish because that's, before we were on land, right?
Right.
Before our ancestors were on the land. Our ancestors, all mammals.
Yeah.
Anyway, because it, has to do with how the brain evolved, right brain, left brain, and the how those things happen. And that's really what she's talking about, is the evolution of the hemispheric nature of the brain and what parts of the body that controls, the left side versus the right side. Well, fast forward billions of years, and when our ancient ancestors started traveling a little more together and really having to communicate a little more than, say, chimpanzees, their ancestors were doing, when they started to develop the first signs of language, that develops in the left side of the brain. The language centers are on the left side of the brain, and the left side of the brain controls largely the right side of the body.
Right.
So becoming more developed on the left-hand side from that standpoint, or at least from that technical standpoint, some people think that led to right-handedness.
That makes sense.
Led to right being the bias.
Right, yeah.
Now, what led to right being dominant to begin with? Why is there one over the other? Why not just be ambidextrous some people actually are?
I wonder if it has to do with language again, because
teaching, I think.
Because, when you don't have language, you're demonstrating, right?
Yeah.
But when you have language, you're using words and you're saying the right side and the left side. And maybe people are learning by hearing those words and just deferring to that rather than watching something, which would be a mirror image if you're watching somebody do something and then kind of choosing their own way to do it. I don't know. That's possible, maybe?
It would be interesting to know, too, there's so many things I would try to observe if we had like time travel and I could go back a million years.
Right.
But you'd want to see like before they were really talking to each other, I'd probably be astonished to see that they have some rudimentary form of communication. They have to be able to not necessarily talk to each other. They're not going to sit down and have a deep conversation around the fire, but they have to be able to communicate.
Yeah, there's got to be something.
Yeah.
Yeah.
I mean, even dolphins communicate, right?
Yeah. I mean, we're seeing human ancestors that are burying their dead. Like, you have to have communication among a group of people that do that.
Yeah.
So
they're communicating, and I would love to see, like, in that early formations of that, when we were 3.5, 4 feet tall and starting to do this kind of thing, like when they throw something, whether it's just something they picked up off the ground, not a developed anything, just like a rock or a stick, do they throw it with their right hand?
Yeah.
And when does that start?
Yeah.
And if they did, is that how tool use or tool construction really became dominant with the right hand, and then that dominance of the right hand makes me wonder, well, is that what helped language develop? Because if you're initially dominant on the right hand, or maybe that's just luck of the draw, that right was, for some reason the choice, or enough people who were doing that were selected for, did that help language develop? Because the right-handedness helped develop the left side of the brain more for language development skills and stuff like that, and language goes hand in hand with teaching. I don't know, it's all crazy.
I don't know. I love speculating on this kind of stuff though, because you don't know, but there's a lot of different things you can think of about why it might have happened, and really like sitting here and coming up with all the maybes and the might haves is really the fun of a topic like this.
Yeah.
As long as you're not saying that it absolutely happened this way.
Right.
Stay away from saying that. But anyway.
So in the last part of this episode here, we're going to talk about one of the articles because I thought it was really interesting, and it's from Live Science 2011. So there's been some more research since then, but what they're saying is not wrong, because Lana mentioned this stuff too. But it's called Ancient Humans Were Mostly Right-Handed Too. And first off, when you get there, you click down on the link. Take a look at the incisors, the front teeth that are in the picture there. It's very obvious that you're seeing differences there. It's really cool. Exactly. Yeah. And, Lana kind of mentioned this, but we didn't really get into it. And I was thinking the teeth showed unique wear patterns for different reasons than this article actually states. So I'm wondering if Lana's research was more current and people were finding additional things. But anyway, we'll talk about that. You heard that interview, so we're gonna talk about this one.
Yeah.
But anyway, the article is basically not talking about how handedness developed, but right-handed dominance.
Yeah, just like how you see it in the archaeological record, basically, right?
And then specifically right-handedness, to be honest. So they took a look at teeth of Neanderthals from about 100,000 years ago and their ancestors at about 500,000 years ago, and found some interesting results. First off, I'll read a quote here from one of the researchers, David Freyer. We are right-handed, and he's making a really firm statement here, but we'll see.
You know how I feel about firm statements, but go on.
Right. We are right-handed because the left side of the brain controls the right side of the body, like we said before, and the left side of the brain is where language is processed. This is important because it tells us that they were brain lateralized just like we are, and they probably had language capacity. So they're saying that, because we can see that there's right-handed. I was kind of saying it the other way around. They're saying it because we were right-handed, they probably had language capacity because that would have helped develop the left side of the brain where the language is processed.
I see. Okay.
But I'm like, well, if being right-hand dominant, did that maybe help the left side of the brain become better equipped to do other things? Like, one of those things being language.
Sounds like a chicken and an egg situation.
I know.
Like
which one?
Which one came first? But or maybe it was simultaneous. I mean, the answer to a question like that always seems like it's somewhere in the middle, some kind of gray area in the middle. But
So the cool thing these guys did was they found evidence of handedness in those front teeth I mentioned at the top of the segment. There are scratch marks on the teeth. And this is where it gets really interesting. Scratch marks on the teeth that show they used their left or right hand to process animal hides. So you could tell the handedness of the person based on the scratches on the teeth. And this is where I didn't ask Lana to get more specific. And I thought what she was really talking about, okay, what they're doing is they have a piece of hide and they need to basically scrape off all the, to be honest, the meat, right? You need to get it down to just the layer of skin that holds the fur, right?
Yeah.
Otherwise, it's going to be super gross. It's not... You're not already smelling too great, but they got to scrape all that stuff off and then let it, sit in the sun and do all the things that it's going to do, right? They got to process it. So in order to do that, they would hold the hide in their mouth with their teeth. And with their teeth. And they would stretch out the hide with their non-dominant hand.
Right.
With their dominant hand, they would use a stone tool to scrape the hide. And where these striations or marks came from on the incisors was on the outside, the front of the incisors, right? The not the lingual, the Lingual
Buckle?
is the tongue side, the buccal side, yeah. And they said that they think it's from when the stone tool just got too close and it scratched their teeth.
Oh, no way.
Yeah.
Oh, crazy.
Yeah, so...
Okay.
But you can see the angle that they're going at on the teeth.
Yeah.
And you know that they're holding it out in one direction
in one direction or the other.
So if you're like holding it out to the left, you're probably right-handed.
Yeah.
Because your right hand is using the tool.
Yeah, totally.
They're making an assumption that the right hand is the dominant one doing the tool because why wouldn't it be?
Why wouldn't it be? It's the one
Yeah.
doing the work. So
Yeah.
it makes sense that your dominant hand would be doing
Right.
that.
It's still an assumption, though. So,
It is. That's true.
Yeah.
I wonder if it's possible that the hand holding the hide out was the one doing the work. Like maybe they were rubbing it on something that was stationary.
Doesn't seem like it because I think we have evidence from going way back that this is how things are processed.
Yeah, probably.
So anyway, they were looking for wear on the surface of the front teeth, and this is where they found it. Where I was getting confused, or I didn't even think to ask because I didn't know I was confused, was when Lana mentioned basically this same study, probably this one or something similar. I thought she was actually talking about, wear marks on the backside of the teeth from holding the hide. You know what I mean? We didn't really talk about the tools hitting the teeth.
Well, there could be other types of processing that they're doing where they're using their jaw or their teeth to stabilize something between their teeth while they're doing something to it. Like I'm thinking making cord or twine or something like that. So that could be the kind of thing that you were thinking of or that Lana was talking about.
Right. So for right-handed people, the scratches went from the upper left side of the tooth to the lower right, and they would use the dominant hand to scrape the hides, like I said. And most of the teeth in the study show this to be true.
Yeah,
you're going to have
really
your outliers that either don't have enough scratches on them, or maybe somebody really was ambidextrous and just switched back and forth.
Yeah.
I'm kind of wondering, like, it doesn't seem like you would really need a dominant hand for that. Maybe you use your dominant hand more often, but if you got a lot to do, you're probably going to be switching back and forth.
Oh, yeah, that's a really good point because your arm gets tired, right?
Yeah.
I mean, when I'm French braiding my hair, like I got to switch hands because like one gets tired after a while.
I mean, first world problems, I guess.
Yeah, definitely.
Yeah. So.
Yeah, that's interesting.
Yeah.
But if most of the evidence points towards this dominant hand doing the work, then they must have really like relied on that one arm to do all that work. Like, the evidence doesn't lie in this case anyway. That's cool.
Anyway, a lot of cool things we found out in this episode. It was not really a news episode, and we like doing these a little occasionally, doing some deep dives on these things.
Yeah.
And I've always kind of wondered about handedness, being an outcast myself. So,
I know. We don't even have a pair of left-handed scissors for you. Now I feel kind of bad.
I make you cut everything.
Yeah, that's true.
Yeah.
You probably like it that way.
Or my little Pampered Chef cheese knife doesn't even work right.
No,
You know that,
it doesn't.
Right?
Yeah, because
Like
the blade's on the wrong side.
It's intended to push the cheese away, and it just doesn't work. Yeah.
Okay,
total
so
BS.
I need to start a Christmas list for you. I need to get left-handed scissors, a left-handed cheese cutting knife, apparently.
Yes.
Is there anything else that you feel discriminated against about?
I tried to learn guitar one time, and they're very right-handed.
Oh, yeah, I bet so.
You got to restring them.
Yeah.
And I think if you do it the right way, like the high note, I can't remember. I don't know the names of the strings. I can't remember. But the high note, the really thin one, is on the bottom. If you're doing it the right-handed way,
course.
I think. But it would be on the other side if you're. So you have to learn completely backwards. Yeah, or you just learn a different. I don't know how you do it. I think you just learn right-handed.
Oh, you might just learn right-handed. Yeah.
So, but I'm not even sure which hand is supposed to be your dominant hand playing the guitar, because one's doing really complicated things with chords, and the other one's doing really complicated things with a pick.
I'm saying that's why I tell knitters that both your hands are doing things, and they're both kind of complicated.
Right.
So don't worry about right-handed or left-handed. Just learn it the way that everybody else does it, because then if you need help, there will be somebody that can help you. And that's probably what the humans said, 100,000 years ago when they were teaching them how to strip hide too. And all of a sudden, now we're all right-handed because of it.
Exactly.
Sorry, you live in my world.
All right. Well, if you're home right now, or if you're on your way home, or if you're going to be home later and you have a fish tank, thank your little fish friend for, their ancestors developing the brains that developed language that helped you be right-handed.
I think you can also thank them for like everything though, right? Like probably also for like cancer and all the other things that like we get as humans.
Yeah, probably.
That are not great. So, it's
forgetfulness.
It's the good with the bad, right?
Exactly.
Oh, man.
All right. Well, that's it for this episode. We'll be back next week. See ya.
Bye.
Thanks for listening to The Archaeology Show. Feel free to comment and view the show notes on the website at www.arcpodnet.com. Find us on Facebook, Instagram, and Twitter at ArcPodNet. Music for this show is called I Wish You Would Look from the band Sea Hero. Again, thanks for listening and have an awesome day. This episode was produced by Chris Webster from his RV traveling the United States, Tristan Boyle in Scotland, DigTech LLC, Culturo Media, and the Archaeology Podcast Network, and was edited by Chris Webster.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.archpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.
People are driven by the search for better. But when it comes to hiring, the best way to search for a candidate isn't to search at all. Don't search, match with Indeed. The hiring process can be slow and overwhelming. Simplify hiring with Indeed. Indeed is your matching and hiring platform. With over 350 million global monthly visitors according to Indeed data, and a matching engine that helps you find quality candidates fast. Ditch the busy work. Use Indeed for scheduling, screening, and messaging so you can connect with candidates faster. Join more than 3.5 million businesses worldwide that use Indeed to hire great talent fast. Listeners of this show will get a $75 sponsored job credit to get your jobs more visibility at Indeed.com/PODKATZ12. That's Indeed.com/PODKATZ12. Terms and conditions apply.